We'll solve this numerical on the stresses and beams, and it says here, calculate the problem and try to conceptualize all this into a diagram. Only then you can capture all the data. It says a 4 meter long wooden beam. So whether it's wood or anything, it really does not matter for us. Only the values matter. It's a 4 meter long beam, and it's not said whether it's cantilever or this one until now. As we read, we'll understand. A 4 meter long beam. This beam is 4 meter long, and is a rectangular cross section. So it has got a rectangular cross section like this. But I'm not sure whether it is like this or like this. When I say rectangle, you can keep the rectangle either like this or like this. It's a rectangular cross section of 200 mm into 100 mm. It's not said whether you should keep the beam like this, or whether you should keep the beam like this, or whether you should keep the beam like this. It's not mentioned. Okay. The beam with the simple supports. So that means it's simply supported beam. It's a simply supported beam. Okay. At its ends is subjected to a point load of 6 kilonewton. So point load of 6 kilonewton at its mid span. So that means 6 kilonewton is applied here. Calculate the maximum bending stress induced when it is placed such that depth as 200 mm. So that means this becomes the first case when this depth as 200 mm, and then when depth as 100 mm, this becomes the second case. So when you keep it like this and like this, which beam will fail easily, you can know. Second is common sense. So, but right now we will try to find out with this, I think, as per the numericals. Okay, now we know that we know the different cases of the max value for different cases. Simply supported with a beam with a point load, simply supported beam with a UDL. Okay, you know that. And what is the formula for a simply supported beam with a point load? Nmax for point load. What is the formula? So last time you saw that, suppose if this is P, then this will be half of P by 2. So P by 2 into L by 2 will be the maximum that will be the maximum bending moment. So that will be equal to PL by 4. So you need to remember this. Otherwise, if you can conceptualize like this and do it, it's okay. Max is PL by 4. So I know the point load here, 6 kilonewton. I know the length here. Length is 4 meters. And divided by 4. What's the answer, guys? What's the answer? So 4 and 4 cancels out. It is 6 kilonewton meters. So 6 kilonewton meter is the maximum bending moment. Maximum bending moment, it is being applied. It is the maximum bending moment applied in this beam. For this beam, we will try to find out what is the stress induced now. Now, we also know from bending equation. From bending equation, we know the bending equation. What is bending equation? MI is equal to sigma B by Y. Using this equation, we can try to find out the bending stress. Bending stress sigma B can be written as M into Y by I. M into Y by I. Okay. So here you can find the bending stress using this equation. So you need to use this equation for these two cases. Now for these two cases. So let us find out for case 1. For case 1. So right now I'll erase this. So okay, there is this part and write down clearly. So case 1. So case 1. So case 1 is what? Depth as 200 mm. So depth as 200 mm, width as 100 mm. When you have this value, what is the value of I and what is the value of Y? So you can find out So when you have like this, I is equal to what is the formula for I? BD cube by 12. BD cube by 12. So what is actually B here? Breadth is this one. Breadth is this one, 100 mm, and depth is 200 mm. Cube divided by 12. What is the answer? Huh? What is the value? Okay, so you got this value, and then for this section I is known. What is y? What is y? So much is y? Y is d by 2, that is 100. So y is equal to 100 mm. So you can know now, from this formula you can know that sigma b is equal to m into y by I. You can directly take this formula here. Sigma b in this case, m, the momentum applied on this beam is 6 kilonewton meter. So I actually put this value here, 6 kilonewton meter. Now all these values are in mm. So this being in meters will actually pose a problem later. So I'll try to convert that into 10 to the power of 3 millimeters, because 1 meter is 10 to the power of 3 millimeters. Okay. So m is known. So m is substituted here. M max is substituted here, because they have asked here what is the maximum bending stress. Guys, here if you apply maximum bending moment, then it will give you maximum bending stress. If you don't apply maximum bending moment, it will not give you maximum bending stress. Okay, so here basically maximum bending stress refers to the stress at the extreme fiber, but what is the maximum bending stress is due to this load. So bending stress is m into y by I. M is written here. Y is how much? 100 mm. I is equal to how much, man? So much did you get for this?
8 times 6.
Huh?
8 times 6.
8 times 6, sir.
0.6, sir.
8 times 6, sir. Like this. Huh?
0.6, sir.
0.6. So this is millimeter to the power of 4. So divided by I. So this. So usually you get 8 times, you said, no? Guys, here you see here, why I write this units is, guys, here I have written 6 kilonewton meter it was, here this kilo is left. So can we actually include this kilo here? So 1 kilo is how much? 10 to the power of 3. So this becomes 6 into 10 to the power of 3 again, 6 into 10 to the power of 3 here. So 6 into 10 to the power of 3, 10 to the power of 3, it becomes 6 into 10 to the power of 6 Newton mm multiplied by this 100 mm divided by this value. So what is the answer that you get finally? So you can substitute this. Now what is the answer here basically? What is bending stress? Bending stress should be, guys, when you write this bending stress, you can't write in thousands, because usually it will be less than 300 or 500. Now what is the bending stress you got? 9 Newton per mm square. So how did you get it? Here mm, here mm to the power of 4. So you got mm square. Here you got newtons here. So it is Newton per mm square. So you got 9 Newton per square here. That is for the case 1. Now let us see for the case 2. Now what is in case 2? So in the case of case 2, you have the beam placed like this. So 200 as breadth and 100 as depth. In this case, what is y? Y is 50. So you can find I. You can find I. So I you can find out here. So I you can find out. So I is BD cube by 12. So B is how much? B for that is 200. 200 mm. Depth is 100 mm. 100 mm whole cube divided by 12. So how much is the answer? 1 7 times 1 7 times 6. 1 followed by 6 7 times. Okay. Okay. I have got the same thing here. So if you want sigma b here, if you want sigma b, then the moment is applied is same. The moment applied is same. So if you want this moment applied is same, so moment applied is 6 into 10 to the power of 6 Newton millimeter multiplied by y by I. So how much is y?
50.
So 6 into 10 to the power of 6 Newton millimeter multiplied by y, which is 50 mm, divided by I, which is 1. So what is the answer here? So this is 18 Newton per meter square. Now you can understand that if you place the beam like this, the stress in the extreme fiber is 9, and if you place the beam like this, now the stress in this extreme fiber is referring to this fiber at the top and bottom, because you have substituted y as 50. So you always see that may I sing for you. So that means stress for the fiber which is at a distance at y from neutral axis. If you substitute y as 50, you get the stress here. If you substitute y as 0, you get the stress at neutral axis, which is 0. So therefore, if you suppose if you substitute this y as 0, then you get the whole thing 0. So it is always proportional to y. Y can vary from 0 to 50. Maximum is 50. So this value of y can vary from 0 to 50. So therefore, the maximum stress will be at extreme fiber here, either at the bottom or either at the top. So depending upon which side bends, if it bends, whether it's sagging or hogging. So suppose if it is bending like this, the top fibers will be in compression, bottom fibers will be in the expansion. So like this you can decide. So this is a simple numerical based on how you keep the beam, and it will decide the stress